Hello, today I will be teaching fork and the processes how to solve question related to fork. So basically, fork is nothing but a system call which will create a duplicate process for the given process on which it is forked. Let's say we have process P1 and we call fork on process P. This will in turn create a child C1 when we make a fork call. So this is basic working of fork. In this, the PID of the child will be unique. It will be separate, different from what is being given to the parent. Apart from that, everything that is available in the parent, all the parameters will be inherited by the child, such as file descriptors, inherited, others, other parameters. Now let's come to this is the basic working of the fork. The parent process is being duplicated when a fork call is made, and the child process will be created with a different unique PID and other parameters will be inherited. These are the process IDs. Now let's come to the question related to fork. So this is basically the fork tree which I have invented to solve the fork questions. So in this question, we have a main process. In this, two fork calls are being made. In case of some error, the process will exit. Otherwise, if it is a child process, printf print hello will be printed, and normal exit will be done. Otherwise, if it is a parent, then printf will be executed, and if in case this exit call is made, then exit 1 will be called and the process will exit abnormally. But this is the trick, I won't be disclosing much about this over here. So let's solve this particular question. So in this, we will draw a fork tree. So in the fork tree, what we have to do is, let's write main process, and I will be abbreviating it as M to show the main process. Now let's write F1 and F2 corresponding to these fork calls. Now let's start with the process tree. First, we will be calling the first fork process. So when this fork is called, a children will be created. So we will be denoting children with C1 and we will be writing F1 corresponding to the first fork. Now we will always write parent to the right and the children to the left. Now coming to the second fork. When the second fork is executed, we will make two branches, both from the parent and from the child. Now let's start with the main first. The main will be executed as it is, and the child will be created, branched out from the main for the second fork call that we have made over here. So let's mention the second child as C2, and consequently for the child C1, the fork process will be called. So we will write the C1 as it is because it is parent, and the new child will be branched out and we'll be calling it C3. And this is corresponding to the second fork call, so we'll be writing F2 over here. So now this is the fork tree for this process. Now in order to execute these calls, we'll be looking at the fork tree and deciding what will be the output of this particular program. So in this fork tree, I have made some analogies. First is that whenever you call the main process, you have to write 1 to the right hand side and 0 to the left hand side of the fork tree. So let's write 1 over here and 0 over here. For this child, the right hand side is C1, so we'll be writing 1, and the left hand side is C3, so we'll be writing 0. Again for N1, we will be writing 1 on the right hand side and 0 on the left hand side. For better clarity, I'll be mentioning the 0 and 1s for the corresponding child over here. For the left hand side we are calling 0, for the right hand children we are calling 1. Now coming to this program again, this line in the fork process, whenever child is created, the execution starts in both child and parent from the line next to it. So let's say if the fork F1 was executed and the two children and the first child was created and the parent was as it is, for both parent and child, the program will start from next line, that is F2. So this is basic of fork. Now coming to the program again, the program will start executing after F3. The program will start executing from if statement over here until the end of the program. Now since there is no, we are assuming that there is no failure while forking, then this particular condition will be commented out, or this won't run, and we will simply skip to this particular condition. Now when we come to this particular, we are assuming that both fork calls have taken place and our final process tree is at this particular state. So now we are checking the conditions PID1 and PID2. For PID1 we can write next PID1 corresponding to F1 and PID2 corresponding to F2. Now when we have to check for the third child, all we have to do is look for the corresponding forks that is above the child C3 in the tree. So for child C3 we will check for PID1 and PID2. Here we can see that PID1 for C3 is 0 and for its parent it is 0. So this will satisfy the condition as PID1 is 0. This is the first true value. So we will print the hello command over here. So our hello statement will be printed for the first time. Now let's check for C1. For C1 the corresponding P1 in the parent fork is 0 and over here it is 1. So let's check the condition again. PID1 is 0. So this is also true. So printf will be printed once again. Now corresponding to child C2, the parent fork value is 1 and for C2 it is 0. So PID1 is equal to 1, so this won't work, this will be false. And for the next PID2 it is 0, then this will be equated to true and the next printf will be printed over here. Now coming to the, after all the childs have executed, we will come to the main process. Now for 1, we will start execution from the else block. As for the parent, PID1 or PID2 will never be 0 as it will receive a positive number for PID1 and PID2 both. So this condition won't execute, and for the parent we will simply move to this particular else block. Now for this else block, there's a trick that I have included in this question, that I have executed my program over here. So my program won't go beyond this and we will simply make an abnormal exit from this program. So this will be the corresponding print statements from this particular program. Thank you.